All right, hello Jake and whoever else is watching this. This is section 3-2. The homework assignment for this is a worksheet again. Yay, we're out of the book. I told you that, right? Graphs of functions. I'm going to wait to give it to you for a little while though, okay? Graphs of functions. Here is the graph that we are referring to. Let's talk about this. Does he go to the left forever? No. He has a solid dot. He stops right here. Does he go to the right forever? No, he has a solid dot right there. Does he touch every x coordinate in between those two?
No, not two.
Why not?
Because there's two open circles.
Because both sides have an open circle. If one of them had a closed circle, then we would be okay. But we have a discontinuity, or like an unfilled value at 2 is what it's called, right? So let's talk about or answer the questions. They say f of 0. That means if my x coordinate is 0, what's the y coordinate? So x 0. What's the y coordinate? Up here at 6.
7. That's 7.
Is it 7? 6. 7. It is 7. It is 7. You're right. 7. F of 3. 3 on the x. F of 3 is 0, I believe. Yes?
1, 2, 3.
Grab a pencil. Write this down. Okay. The domain.
Get it together.
Is
How do you want to write the domain? There's a couple different ways we could do it.
bracket 8,
Bracket.
comma,
Is it 8? It's starting at an x coordinate of 8. Okay, got it. Comma.
2 parentheses union
2 parentheses union.
bracket at
Shouldn't it be negative 8? Yeah.
Negative 8. Yes, you're correct. Negative 8, comma, 2 parentheses union 2, comma.
7.
Is it 7? 7 bracket. Okay. Oh, bracket. Okay. You could also instead, if you wanted to, you could put negative 8, comma 7, both brackets, but then say x is not equal to 2. You could do it that way as well, whichever way you want. It doesn't matter. I think it's probably about the same amount of writing no matter what you do. Okay. But that just notes that there's a break at 2, so it doesn't touch 2 exactly. Make sense? Good? Okay. All right. And the range is up and down. Okay. So range, here we go. What's the lowest he goes?
Negative 9.
Negative 9. Is it a bracket or paren? Bracket, comma. What's the highest he goes? 8. Does he touch every value in between?
Yes.
But like even here, he's touching there and there x coordinates, right? Like he's touching there, and even here he's touching there, right? Like he's touching every y coordinate all the way through. So that should work, right? Does that make sense? It's a little bit harder to see that with the break in there, but he is still touching. There's some places he touches at 3 places on a y coordinate, right? Like if I draw a line through here, he has 3 y coordinates where he's touching. Make sense? Yeah? Okay, so there's that for a range. Happy with that? Vertical line test, what does that tell us? Function or not a function? So this one, function or not a function? No, this is the graph of like x equals y squared. If you want to, you can write that down. X equals y squared is another way of saying y equals plus minus square root of x. Those two mean the same thing. Okay, x equals y squared or plus minus square root of x. That's what that graph is. Okay, the second one, this one right here, function or not a function? Yes, vertical line test passes. What is this a function of? Probably x to the 3rd power. Kind of looks like a tangent function for my calc kids who just got done doing that, but it's not. It is x to the 3rd power. Okay, good?
It's not. No, it's not.
Yes, it is.
It ends.
What? Well, I mean, like, it is x to the 3rd power, but it is restricted. The domain is restricted between probably negative 5 to 5. So it is still the graph of x to the 3rd power, but it is restricted with a domain of negative 5 to 5. Make sense?
Those things matter.
Or a range from negative 8 to 8, right? Okay, but it is still the graph of x to the 3rd power. Okay? All right. So let's talk about increasing, decreasing constant. So increasing means it's going uphill from left to right. Decreasing means it's going downhill from left to right. Constant means it's a horizontal line and it's staying steady the whole way through. We just got done talking about this in calc. Woo woo. Yes.
It's going like this.
Then we will have different intervals for when it is increasing, when it is decreasing, when it is constant, and we'll have to separate it out, which is what we're going to do here, right? Where a function is increasing, decreasing, constant, okay? They have gone ahead and graphed for us. We don't have to do this, but on your homework assignment, you may have to plug this into your calculator and graph it. So how do I graph that thing? Like, where do I go to graph it? y1 equals, and you put your absolute value stuff in there, and we want to know where it is increasing, where it is decreasing, where it is constant. Okay? You're going to have those three things labeled. Okay? You can fill them in if you want to. It doesn't matter. You don't have to. Right? Okay, or you can graph it if you want to. If you want to practice graphing, there it is. Okay, but this is what he looks like. Okay? Okay? Let's find these important parts right here. Where is like this point located? What's the coordinates of him?
0, 2.
0, 2, I think. You're right. Okay? And what about this point right here?
It's like
2, 2, I think maybe. Right? Okay? All right, so when we talk about increasing, decreasing constant, we do not care about y's. Y coordinates don't matter. Exclamation point. We don't care about the y coordinates. We don't look at the y coordinates. We're only looking at x's because we're only going from left to right. Okay? So starting at the leftmost side of this graph, like scanning the graph going this direction. Okay? What is he doing first? Increasing, decreasing, constant. He's going downhill, okay? He goes downhill from negative infinity until what point? 0. We don't care about the x coordinate, right? So we don't care about 2. So from negative infinity to an x coordinate of 0, he is going downhill. Do you agree with that? Okay. Now he is doing what next? He is constant from what to what? 0 to 2. Constant 0 to 2 paren. Okay, I'm going to tell you why it's a paren here in a second. Okay, then at 2, he switches and he's going this way now. He is increasing from 2 to infinity. Okay, now, will every graph have one of each?
No.
Some graphs won't be constant, right? The majority of graphs won't be constant. Some graphs will only be increasing. Some graphs will be a combination of both increasing and decreasing. You might have 2 chunks where it's increasing, 2 chunks where it's decreasing. If that's the case, you put a union in between. Now, why do we put only parens and not brackets also? What do you got?
Because it's a point. If you say it is a specific point, then it's just a point. It's not actually.
So what they're saying here is by putting this as a paren for increasing, decreasing, constant, they're saying that it is neither increasing nor decreasing nor constant at that point because it is switching direction. So we do not be inclusive. We don't do a bracket when we're talking about increasing, decreasing, because at that point is where it's changing, so it's not one or the other. It's just a point, okay? So that's why we do parens instead. Good? Happy with that? Okay, finding local maxes and mins. Do we know what maxes and mins are? High and low points, right? Okay, so for this graph, they've had us graph this thing. It looks like this guy. And I don't know about this thing. Find all local maxes and mins. Why don't we try graphing this on your graphing calculator? Because I can't really see if it dips down. Does it dip down? I don't know. We're going to zoom. Okay? So go to your, use your calculator, type that function into your y1, and let's see what we get. Type it into y1. We're going to see if it dips. You might have to zoom in on the little humps, and we're going to figure out where the high points are and the low points are. What?
On our maxes and mins, do we have to do y coordinates then too?
Yes, on maxes and mins, you do need y coordinates because we're looking for the coordinate point, okay? And these are going to be estimations, folks. Kind of like we estimate the x-axis, like the x-intercepts, we're estimating. So I'm thinking, if I remember right from last year, I'm thinking that this thing does go up and then it comes down slightly. So we will have a maximum like here and we'll have a minimum right here. But look and zoom and see what we've got, if you would, be so kind, okay? We're looking for x and y coordinates. So use your little cursor to move him and find where that high point is, okay? See what you got.
Yep, that's what.
Does it dip? It does? Okay, slightly. It's not very much, right? So see if you can find where that high point and low point is. And give me the coordinates.
That is a lot of work.
It is a lot of work, I know.
At a point, it's just constant. Just constant.
Okay, so what we're going to do is we're going to say that the maximum is like halfway between. Does that make sense? So I'm going to go my cursor. I'm going to go like about there-ish. Is that the maximum? 0.44 and 1.18. Okay, 0.44 and 1.18, comma. I need to like have a, here we go. 0.44, comma, 1.18. Okay, this is what James got for a maximum, about that point, okay? He zoomed in so far that like, let me talk to you about this maximum. He zoomed in so far that at one point on his calculator, it went like this, and then it almost looked like a straight line, and then it went back down again. So I said your maximum point, because you're zoomed in so far, your maximum point is gonna be like right here in the middle of that, right? So if you do get like a horizontal line, it's not a horizontal line, you're just zoomed in really far, and that's where like the line glitches, it's gonna be like that halfway point, okay? Which is about at 0.44, comma, 1.18. Does somebody have the bottom one?
0.625.
0.625, comma,
I got 0.773
0.773 for the X or the Y?
Well,
for the X.
yeah, for the X.
0.773?
But I went to
got
the middle.
0.7,
That's how I got
so close
6.25.
enough.
So close enough, yeah. 0.76 or 0.773?
Oh,
So I don't know.
And then
yeah, it could be
1.15.
1.15 for the X, for the Y?
Here, look at
For the X.
1 point, no,
No, for the Y.
For the Y.
1,
Excusing myself.
7. Right? Would you say that's middle?
Yeah,
Oh my
I mean,
goodness.
yeah, maybe over just a tad. So 0.59 or 0.6? Yeah, like maybe
Yeah.
0.61
That's
or
why I went
something.
to 6.25.
Here's one.
Yeah, 0.625. Yeah, yeah, that one's kind of tough. So how do we settle this? Because those are kind of off a little bit, you know? Let's do this. Here's how we settle the argument. Ready? Go to table set. So second or shift window. Go to shift window.
And then go
Okay.
to the table.
And table set, we're going to start at 0.6 and go by 0.01 maybe.
Wait,
I
what?
already canceled out the equation.
Oh. Somebody else have it on their thing? Okay. So we're going to go second table set. We're going to start the table. Table start at 0.6 and go by 0.01.
Look at number 9.
Okay. And we're going to go to the table. So the second table.
Do not try this at home.
No.
But it has a promise about like standing on the edge of a ship and like jumping. But you can't drive your car. Don't do that at home.
Made it worse.
And we're looking for, is this the low point? This is the low point?
Yeah.
Okay.
Jake is
So-
gonna have to sit here and like skip all this. Like, what is going on?
Okay, so if you go on your table and you scroll up and down, it goes from like 1.1 something, and then it goes down all the way, like we're looking at the Y. 7.6.
Walk around barefoot the rest of the day.
Yeah, we're gonna go 0.76. 0.76, comma, 1.1593. Okay, so if you looked at your table, we had like 0.74 and 0.75 and 0.76 and 0.77 and 0.78. You don't have to write this down, but this is what your table looked like, right? 0.74 was at 1.1595, 1.1594, 1.1593, 1.1593, and then it was back up again at 1.1594, okay? So we're looking at these y coordinates. Do you see what's happening? It's going down, it's going down, it's staying the same, and then it's going back up again, right? You see how that works? Like from one to the other? So like this is where he's at his lowest at 0.76 or 0.77. Do you see how that works? Okay, so we look at the table and look at the y coordinates to see like where it's going down and where it's going back up again. So if you want to get really super close, you can use that feature, yeah? So there's your maxes and mins. Good deal. Okay? Good? Yes? All right, let's keep on moving. Go to the back side.
We have
Hey.
15 minutes.
20.
We could put on homework for a little bit.
We'll stop after example 5 because these go together.
Fine.
These go together. Concave up and concave down. This is something you calc kids and Jake, So Kyle, Luke, and Jake, here we go. Concave up and concave down. We are going to discuss this really in depth in chapter 5 in Calc. And it is kind of somewhat related to increasing, decreasing, but not really, okay? So a lot of people confuse concave up, which I abbreviate as C up, because it stands for cup. And a concave up is making a cup. It's holding water, right? So like this is concave up. If I pour water into it, it is going to hold water like a cup does. It's concave up, yeah?
That would
Now,
not hold water very well.
It is not necessarily true. Ready for this? It is not necessarily true that concave up is always consistent with increasing. For example, I can have this is concave up and increasing, right? This is an increasing function. But I can have it be decreasing and concave up. Here's what it looks like. It's cupping the other direction, but it's going downhill from left to right, correct? So this is concave up and it is decreasing. So concave up has nothing to do with increasing, decreasing. Yes, sir. What?
You have concave down.
Yes, we're going to do
What
that.
if it's just perfectly sideways?
If it's perfectly sideways, then
That's
it's not a
a plate.
function.
What if
Then
it's
it's not a function. It's not a
Sideways?
function. What?
That's function.
What are you talking about? If it's a straight line, then
Yeah.
it's neither concave up. It's constant. It's not concave up or concave down.
okay?
Okay, but what I'm saying is, like, if it's concave up, it's not necessarily always increasing. If it's concave down, it's not necessarily always decreasing, right? Okay, so this one is a concave down. It is shedding water like an umbrella does, right? So if I pour water on top of it, it is shedding, it is caving downward. So I call this C down, okay? Now, C down, ready for this?
Just like a
Take a look at this function, okay? All right, take a look at this function real quick. This middle one, this is concave down. The entire thing is concave down, yes? Like the whole graph is concave down. It doesn't switch concavity, okay? We'll talk about it switching concavity here in a second, okay? This whole thing is concave down, but it is increasing from here to here, and then it is decreasing from here to here. So the whole thing is concave down, but it has two chunks of where it's increasing, decreasing, right? So it doesn't even go on the same intervals at all. All right, now let's look at this one. Okay, are you ready for this? I'm going to put some points in here. So pretend these points. Let's talk about this point right here. And let's say this point is at 1, 2. Put these in. We'll make these points up. Let's say this minimum point is at, I don't know, 4, negative 4. We'll go 4, negative 4. Put these points in. Okay, and then this top point right here, we'll call that negative 3, 7. Okay, let's do that. All right? Okay, we're going to dissect this entire graph. Ready? With those points. I just made those points up, but this is what your homework assignment will look like, okay? So here we have this. Ready? Okay, we're going to talk about increasing. We're going to talk about decreasing. We're going to talk about constant. We're going to talk about concave up. We're going to talk about concave down. We're going to find the maximums. We're going to find the minimums. And we're going to find the points of inflection, which I call poise. That's a lot of stuff, okay?
Too much.
Lots of stuff. All right, so copy those down. We're going to dissect this graph. Here we go. Maxes or mins, because there might be one, more than one, right? And then I should have POIs, because there might be more than one POI.
What is a POI?
A point of inflection. An inflex point is where it changes concavity.
Person of interest.
Person of interest. It is a point of interest, actually. It's a point of inflection, an inflection point. All right, so here we go. Ready? Let's do the stuff that we know how to do first. Increasing. He is increasing from here to here, correct?
Negative infinity.
That is from negative infinity until we get to
Negative 3.
negative 3, according to the point that I just made up, right? And then he starts decreasing. He is decreasing from
Negative 3 to 4.
negative 3 to 4. Shh.
Which
Don't.
means that negative 4 to, or 14.
Okay, I need to erase that because that's glitchy. Negative 3 to 4 is decreasing. Then he turns around and he's increasing again. From 4 to infinity. Where is he constant?
Nowhere.
Nowhere. He's not. So we put that in there. Okay? Good? Happy with that?
Yeah.
Okay, now from left to right, is he caving up or is he caving down first?
Down.
He's caving down from here until we get to where?
1, 2.
He's caving down until we get to here, and then he starts to cave upward again. Do you agree with that?
Yeah.
Okay, so notice that like my increasing cutoff at -3.7, that's not my same interval as the concave up or concave down. Like it's gonna cut off at a different point. That's called an inflection point, okay? So he is caving down, so I'm gonna go to concave down. He is caving down from what to what?
Negative infinity.
Negative infinity until I get to 1, right? And then he turns around and from here to here he is caving up. He's holding water, right? From 1 to infinity. Okay, good? All right, now let's do maxes and mins. Maxes, how many maxes do I have? 1 at -3.7. Okay, mins, 1 at 4, -4. Points of inflection is where he switches from concave up to concave down. 1, 2. Now, will he always have 1 max, 1 min, 1 point of inflection?
Probably not.
No.
Is there times where he won't have a maximum but will have a minimum?
Yes.
Yeah.
And if that's true, then it won't have one of the ups or downs.
Right.
And if he doesn't have that, then he doesn't have the PLI.
Correct.
And if he doesn't have that,
Correct.
then he's more than likely not constant. And
Right. Yeah. Got it? Okay. So this is all of the stuff, yeah?
So we're done. We'll be done.
Okay, we'll analyze example 5 tomorrow. Okay.
Okay.
Goodbye.
Bye, Jake.
I'll give you your assignment though.
What's a convex
Go
down? That'd be
get it.
concave.